All right, everyone, welcome back to Machine Organization and Programming. Today we're going to be taking a quick look at file input and output. All right, just a couple of notes as we begin. We're going to be looking at two different ways to do this. First, using the C programming fopen, fclose, fread, fwrite options. Note, this is talked about in our book in section 7.5 through 7.7. So that's the C version. We'll also be able to use Linux system calls to open files. That's the same way you could from the Linux command line, using open and close, and then read and write. And that is going to be talked about in the book in section 8.1 through 8.3. All right, guys, so the next thing I want to talk about is reading and writing to files. So looking at what we've got right here, this is my file1.c. I've got 3 examples for us today. This is just an example of opening a file and reading from it. So if we go through here, I'm defining max. This is a great way to just create a constant that I'll be using for the size of everything, because C does not dynamically allocate things. For example, right here, I'm creating a character array to hold all of the data that's being read from the file in buff. And let's see here. I'm also creating a file pointer variable. So check this out. The star here tells me it's a pointer. This is a file pointer. So this is just going to be a stream of characters that we can read in from. To use that, I'm going to assign that file pointer from the function fopen. And the file I'm reading, so here are the options. The file I'm reading is going to be this gatesquote.txt file. That should be available in the code download section on Canvas. And we're going to be opening this in read mode. One sec, I'll pull up the man page for fopen. We can see all of the different options. Okay, and then what we'll do with it is we're going to just go through. We're going to use fgets. This is going to just read a string of bytes from the whatever the file pointer is pointing to, and it's going to read at most this number of bytes. So this is why I'm putting this in here. If I didn't have this maximum value to decide how big my character array is, I could easily overrun this buffer and fill it with more characters than will actually fit in memory. So this is why I'm using this numerical constant for the size of things. Way better than hard coding, because I only have to change it in one spot if I'm suddenly going to be reading a bigger file. I'm doing this in a while loop right here. Fgets is going to read until it runs into an end line or an end of file marker. And it returns that either the character it reads, or if it reaches the end of the file, it returns the ELF, which is going to evaluate to false in a while loop. Again, I'll pull up that man page in just a second and highlight these. Then all I'm going to do is print out that buffer as a string. And then at the very end, I need to close my file pointer with fclose. This is important because you can only have so many files open at a time. When this program ends, the operating system will take care of closing all those files for me if I forget. In my third example, I'm going to talk about something that doesn't do that. It's just very good practice to make sure that even if we only have one file open, that we remember to close it when we're done. And this is is talking to the operating system, because there's a communication there between the disk and your program in C. All right, let me go run this. We'll show you that it works. You can read the awesome quote, and then I'll pull up those man pages. All right, guys, so I just compiled it successfully, and I'm going to run it in 3, 2, 2.5, 1. Okay, so there you go. The computer was born to solve problems that did not exist before, by Bill Gates. One of my favorites. And we can see that it's working. If I go to that file, let's see what that called. Gates. Yep. I can just see there's the only thing in this file is that quote. You guys can download that yourself. Let's get out of here. And now I was going to pull up the man page for fopen and take a look at that. I wanted to highlight a couple of things. Let's see here. Yep. So it requires a path name. In this case, I can either give it a character pointer, so a pointer to basically a string in C, or I could, what I did was I just hard coded the file name as a inside quotes as a string literal. And then it also requires that character for the mode. This is again going to be a character buffer. So if I'm putting this in a character pointer, so if I can have more than one character here. Let's see here. I wanted to highlight, let me scroll down a little bit, all the different modes that are available to us. So I was using R. So this is just going to open the file for reading. If the file doesn't exist, it's going to return null. So I'm going to go back in a second and add a check for that because I didn't do that. That first program doesn't have great programming style practice. R plus will open it for both reading and writing. It's the same thing more or less as W plus. I believe this one will fail if the file is not open. It'll return null. And this one will create a new file if it does not exist. So that's the difference between the W and the R plus version. And if we just open a file with W, even if there's a file there, it's going to delete the contents of the file and prepare it for writing. So we're going to nuke whatever's in the file. A is sort of the append version of that. It's going to keep whatever's at the file and put the position where it's going to write at the end of the file. And A plus is just going to create the file if it doesn't exist. If I'm reading, or if it allows me to read from it and append to the end. So if I just go ahead and start writing text to this, it'll just put it at the end. Okay. We can also add the character B if I'm writing to write the text in binary. So WB would write in binary. There we go, right there. And where's the return stuff? Yep, the return value upon successful completion returns a file pointer, which is a non-null pointer to like a location in memory. It's treated just like reading from memory. Otherwise, null is returned. Error number is set, so you can read that from the command line later. Okay, yep, so that's what I want to do here. And then I also wanted to open the command page for fgets. All right, there's a bunch of different versions of getting data. This is just another way to read from an input stream, like the keyboard or from a file. So the version I'm using right now is this fgets. I gave it a character buffer to fill in. I told it how many bytes I want to read, and then I gave it a source, and this was my file pointer. So basically fgets with a C is going to get a character. Fgets without that is just going to read however many characters I tell it to. And the return value, this is the part I wanted to focus on, is the character that's read cast to an integer or EOF. And EOF is going to evaluate to false if I use that as a condition. All right, let me move on to the next example. I lied, I wasn't quite ready to move on to the next example. I wanted to show that I did not do great programming practice here. I'm using fopen without ever testing to see if this file really existed. So here's what I'm going to do instead. I'm going to just add a conditional. If fp is equal to null, that means this has failed. So instead what I want to do is just return 1. And the 1 there would be a signal that this is an error. It did not return normally. Could also use exit 1. That's a system call that's going to just crash the program immediately. I would prefer that one if I were using this inside of a function, because that will end no matter where I am. Return inside a function will just parentheses where I don't need them. We'll just go exit the function. Okay. Let me make sure this still works. I didn't mess up. There it is. So no problem. Next example. All right, guys. So in this example, I'm going to be writing to a file and then reading it back just to make sure that it really worked. And again, all of this input-output stuff is just in standard I/O. So, and again, to use this, I'm going to open a file. So I'm creating a file pointer. So this is going to be a location in memory where I'm going to be interacting with my file through the operating system. Fopen returns that location as a pointer. And I'm using WB as my option here. So I'm going to be writing this as a binary file as opposed to an ASCII file. You guys can experiment by taking that B off and just see the difference. All right, and I'm calling the file bar.bin. So foo and bar are typically used when we don't know what to do for a file name. So I'm going with bar this time. And bin is sort of the abbreviation for a binary file. If I were writing this as an ASCII text file, I would have gone with txt. And here's what I'm doing. I'm just going to write down this number, hexadecimal, 1 through 8. All right, now, because I'm opening in write mode, I'm going to use fwrite as the C command to write to a function. That takes 4 options in this case. I need to tell it what I'm writing, and this is going to be more or less a pointer or assigned to a pointer inside, so I need the address of something if it's just a variable. If it's already a pointer, I can just leave this as without the address of. And this is going to write a number of bytes, but it's going to do it in, it takes 2 options to get there. So it's going to ask for the size of whatever we're writing. So if it's an integer, if it's an object, if it's a character, I'm just going to give it however many bytes are in my integer or character or short or whatever, system dependent, may change in the future. And then how many of those things I'm writing. So it's assuming that I'm giving it an array. And if I have a string, I want to make sure this is big enough to include the entire string. And then where to write. And again, this is this file pointer is how I'm interacting with the operating system to make sure this gets put on the disk. And as always, close your files. We only get a certain number of them open. And again, this version where I'm using f open is going to return the file as soon as the program is going to close the file for me. When I get to the end of my program at this return line, the operating system will take care of that for me, but it's good practice. Okay, now in part 2 of this, what I'm going to do is I'm just going to go ahead and open my file again. I'm going to reuse that same file pointer. So this will just be assigned a new memory location where I'm interacting with the operating system to open that file. And I'm going to be opening it in read and again binary mode because this is a binary file. Declare a variable so I can read the number into it. I don't want to use this same one because that already has the number, and I want to show you guys for real that I'm doing this correctly. So we'll be reading that number, and again, fread takes a location in memory where I'm going to be storing something. This is not a pointer, it's just a regular variable, so I need the address of that. And again, fread requires what I'm writing, the size of whatever I'm writing, how many bytes. There's another option here for if I'm giving it a size of number of bytes and how many integers I'm reading or how many things I'm reading. And then the pointer where this goes to. So this is the 4 option version of that. All right, and then, yep, I'm just going to print this out to the screen as a hex number so I can see that it worked. And again, I'm closing my file pointer. All right, let me go ahead and run this. And here, I'll cut the video so that you guys just see the results and don't need to watch me type. All right, guys, so I compiled it. There were no errors. I'm running it. And what I can see is that the number that I read in is indeed 1, 2, 3, 4, 5, 6, 7, 8. So looks like it's working. All right, and just one more thing before I move on. If I list the contents of my directory, I can see I've got bar.bin right here. And if you remember, we have this hex dump command, -x, there we go, -x, and then bar.bin. I can read the contents of this file. So this first number here is the position number. This is the memory location, essentially, where the file begins in bytes. And then it's I've got the number here, 1, 2, 3, 4, 5, 6, 7, 8. But what we can see is that they chose to write the bytes in what I would consider an interesting order. So at position 0, we've got 56, and then at byte 1, we've got 78, and then at position 3, we've got 12, and then 34 wrapping it up. And then nothing, this would be the end of the file here at byte 4. So, all right, guys, I just pulled up the man page for fread and fwrite. Here they are. Stands for binary stream input and output. I just wanted to get you guys used to pulling these up yourselves and looking and interpreting them. So here we go. These are the 2 functions right there. First, the fread function. This is the function prototype that tells us what all the parameters are and the return type. Okay, so the name of the function is here. It takes 4 pieces of data as parameters. So the first one, essentially fread assumes that we are reading in an array. It could be an array of characters, could be an array of integers. Anyway, this pointer, it's a void pointer because it'll be cast to whatever data type we are actually writing. So if we're writing integers, it'll take care of that for us. So we need the pointer to the array where we're writing. We need the size of each element in the array. If it's an array of integers, we're looking at probably 4 bytes. Use size of int in case it changes in the future. If it's a struct of some kind or an array of structs, then we'll need size of whatever we have named that struct. And C knows that's how big it is, so use size of again. And then we need to know the size of the array. How many members are in that array? And finally, we need to know what file to read from. So this is that file pointer. Return something of size t. And what this is going to be is the number of data items that have been read. Let's see, where is that? Return value. returns the number of items that have been read or written. I may have misspoke a moment ago and said something different. Apologize if I did. Anyway, should an error occur or we're actually at the end of the file, the return value is 0. And if we use this in a while loop, 0 is going to evaluate to false. All right, similarly with the write function, this is also going to return the number of items that have been written or read, written in this case. We still need that array that we're reading from. It's constant in this case because we're not going to be changing it. We're not writing anything to it. The size of the element, so use size of, if it's integers, size of int. The number of members, and again, this is size t. Size t is just an alias for, I believe, long, so an integer data type. And then we need what file we're writing to, and that's all there is to it. All right, guys, I just want to show you one more way of writing to files. I'm using open here instead of fopen, and I'm using write instead of fwrite and close instead of fclose. These three are actually Linux system calls, and C will let us do that. So this is not regular C programming. It's calling a Linux program. So I don't believe this works on Windows or on a Mac. It might, and it may behave differently. One of the major differences is that if I'm using a system call to open a file, it's not automatically closed when this C program ends because it's not a C function. And the operating system will leave it open for us. So this one's a little more dangerous in my opinion. You have to remember to close your file. So the way this open works, it just requires the name of the text file, or the name of the file we'll be writing to. And then it has all of these different options. We're using the OR here. So this is actually creating a bit field. So all of these would correspond to one bit in an integer that gets passed in. So O stands for option. I'm going to be creating a new file. I'm going to be writing only, so I won't be reading. And I'm going to be writing at the end of whatever's already there. This create doesn't like nuke whatever's there. If it just creates it if it doesn't exist. I don't remember what this one does. All right, and then this FD, the value that it returns, is sort of the operating system control number for that file. You can print it out and see what it is. It's assigned a negative integer if this open fails. So that's what we're going to test for to see if there's an error. And you guys can go open the man page and read exactly the return type of this, just to refresh your memory if you're ever using it. But here's the idea. I also wanted to highlight that I'm using fprintf a little differently. So we've been using printf up through now. That's printing a format string. The F here in the front says we're going to be printing to a file, just like fopen, fclose, fwrite. Fprint is printing to a file, and it takes as an argument whatever file I want to print to. By default, the printf without the F is going to go to standard out, stdout. That is the screen. Standard air by default also goes to the screen. This F just means I get to tell it where I want to write. And I can use the name of a file right here, or a pointer to a file, to decide where this goes. So in this case, I'm just going to be writing to the screen. A lot of times you'll redirect this standard error to like a log file or something, or an error file, so that if your program crashes, for example, in the future when you guys are working on real production code at your job, you'll probably have something like this that should your customers find out that the program crashes, you'll want them to send you an error log so you can fix the bug, rather than just trying to guess what they were doing. This is how you'll do that. All right, and then we're, let's see, down here we're using write instead of fwrite. And again, this is a Linux system call. It takes that, which file I'm writing to, and they're given like an ID number. And then the next argument is what I'm printing, in this case, hello world. And this is how many bytes I'm going to be printing. And this needs to be at least equal to however many bytes right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got one extra for the end of file. And then close this. Definitely close it. All right, let's go make sure this works. All right, so let me see here. I'll go ahead and do the, grab that. This is file 3 and 3. All right, then we'll just run this. File 3. Now I should see that I have created testfile.txt. And it wrote it out as a binary file, so this program actually believes that this is executable. Let's take a look at it. and just verify that it is written in ASCII code. So we can actually see Vim will translate anything that's in ASCII to this characters we can read. And then this stuff at the end is garbage because I printed one extra character that cannot be printed as an ASCII character. All right, I just pulled up the man page for open. Again, this is a Linux system call. It's in the Linux Programmer's Manual. In order to use the open function to open a file for reading, we'll need to include these libraries so that C knows what to do. And then this is the function we're looking at, the function prototype. So it's going to take the path name, and again, I just gave it the name of the file in quotes, and then a number of flags. So we'll talk about that in a second. It also returns an integer. So let me scroll down. There we go. And let's see here. What we're opening, what it returns is a small non-negative integer. That's the file descriptor. So every file that's open, Linux keeps track of that with a number. It gives it an ID number. And it's basically going to return that ID number for the open file. It's going to be the lowest unused number. It returns -1 if anything went wrong and it fails. For example, if there's too many files open, it's going to return -1. And then that's also going to set the error number environmental variable, and we can go read that to figure out exactly which thing went wrong. There's a table at the bottom of how to get that. I'll go to that in a second. All right, and also note that it doesn't close it, even if your program ends. So it's designed to remain open, even though your program may end. All right, and then let's talk about these flags. So we must include one of these. You must have exactly one of these. We're either going to read it, write it, or read-write both. And then we can also use bitwise OR to add extra options to that. And there's a whole list of extra options right here in the table. I just wanted to point out that the option I chose, the one I said I didn't know what it does, it's right here. It stands for giving the file permission to read, write, and execute. You may have noticed when I did the ls that it was my file was green and listed as executable. That was a poor choice. I probably should have chosen the one that just read, write. Let's see, where is it? Oh, I need both of these. I would need this one and this one to add read and write. Yeah, all Linux file permissions have 3 sort of like access levels. So there's the actual user, the file owner. You can assign groups to things, and then people who are not part of the group. So that's why there's so many options here. And then let me scroll down much further. Yeah, here we go. Here's all the different errors that can happen. All right, so if there is an error, instead of returning the new file descriptor number, it's going to return a -1. And this happens regardless of which error. We just get the -1. In order to find out which error happened, the error number environmental variable is set, and we can just look that up. And here's some of the errors that can happen. Let's see, there's a big list of things, so we can just look up which one it is. I'm looking for something meaningful here. Yeah, here's a good example. So eaccess error, an access error, would indicate something like we don't have permission to write to the directory where we have requested the file be written to. Something like that. And we can see there's a lot of them here. Default outside of our addressable address space. The error is directory. That means we've selected the path name as a directory, and we wanted to write data to a directory instead of a file. So things like that will go wrong. So if you make a mistake, you'll get the -1, and you can just look up what that is. All right, have a great day, everybody.